Hello everyone. Today, this is the first time I've ever done something like this, explaining stuff, because I did it by myself. I feel really proud, and I just want to do it. Okay, let me find a program. Unedited video, by the way, because I'm lazy as hell. Okay, so this problem says that digital river is a sequence of numbers which has a rule. So first I'm going to define this function. Pi of n is the sum of all digits. The sum of digits in n. And the sequence S of n, with n as the first item, would be something like n, then n plus pi of n, then this entire thing plus the pi of this entire thing. I believe that's right. I don't know if it's an exact word for this, but I guess this function has independent the sequence has independent subsequences inside of it because each item is dependent on the previous item, which is S of n(i) is S of n(i) minus 1 and pi plus pi S of n(i) minus 1. So if you ever have... Oh, is this right? Okay. So if you have this as a starting item, then you're guaranteed to have this. And this digital river is K if it starts with K. This is the example I'm going to use. So digital rivers can meet. This happens when these sequences can meet if the sequences have an intersection. Given a number R1, I'm gonna actually use G as for this instead of R1 because I have absolutely no idea what R1 is. So I would quickly like to say that A less than B implies that A is not inside of S of B, but if we have S of A, then might have S of B. That's why this entire program that we're writing, it searches for inside the search space, which is lower than B, because any S of C larger than B, it would not contain B. So we have this input chi. It is an intersection if chi is in S of A and chi is in S of B if A is not equal to B. My first guess was that we construct an omega which is from 1 to chi. Then we aim to find chi in S of any item in omega, so that and then it halts. So, and we know that if any S of any item in omega J, if this doesn't contain chi, then this doesn't contain chi too, because it's a subsequence inside of this. So if this doesn't have chi, then this is guaranteed to not have chi. Originally, I would have thought that. I thought that, and I made some improvements. So since they're independent subsequences, it would be rather really better if we only found S of omega I 2, so that it would be chi. Basically, any omega I, so that it's lower than chi, and the direct next step is chi. Like this. So I would take the minimum of n, so that it's like a generator sequence. I'll start saying generator sequence, so that the second item of the sequence of n would be chi. And for that, I will maximize pi of n, and pi of n would be biggest if all of its digits are 9. So n plus, we substitute in pi of n, the minimum of n would be chi minus if all digits were 9. All right, let's do this. So I actually want this to be chi, because it's hard working with R1. We define pi of n, so that it's the sum of I in int I for I in n, which is an integer string of n. This is sum of digits in n. And def check for intersections. It could just be the main, because it would take in chi anyways. So yeah, we construct omega so that I have not actually started to build a pseudocode for this yet. That's why it's easy to explain all of this, but it's hard to like make the program like this. I'm trying my best. Here, this is the unoptimized, but we can use the minimum of chi minus 90. Hold up. I remember the code is super short. No, we don't need omega, we just for a loop, because we don't exclude anything. In my original omega, we have to exclude the values. There are generators for subsequences in omega, but now there shouldn't be subsequences. There should just be generator sequences. So range if it immediately generates X, then return yes. Otherwise, it doesn't find it and returns no. Then we print main of chi. Just need to find this, which is the limits. And it's the minimum. This is the minimum. Because the range from that to chi. That would be chi minus 90. Hope it goes well. Oh my god. Oh my god. Oh my god. Oh my god. Okay, hold up. Yes! 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 Okay, thank you for watching. Bye. Oh my god.